We're on page 10 here. We're going to do something called implicit. That's derivatives with multivariables. We're going to be taking the derivative of this x squared, this y squared, and this 16. Could be kind of complicated. So the first thing I want to do is take the derivative of x squared, which is not too daunting. That's just 2x. But this is the strange part. When I take the derivative of y squared, it's going to be 2y and minus the 1. But now, because I'm taking the derivative with respect to x, I'm technically supposed to put dy dx behind it. I take the derivative of 16, and that's 0. So I don't like to write this dy dx when I'm doing implicit. I prefer to write it as y prime, as I have been. So 2y times y prime equals 0. Now, you must solve for y prime. Because in all the other problems, didn't we have it as y prime equals something? Didn't we have it as y prime equals something? Y prime or dy dx equals something? So I need to set this equal to y prime. I need to find out what y prime equals. So I'm going to subtract 2x from both sides. That would give me 2y times y prime equals 2x. And then I'm going to divide both sides by 2y. And that's going to give me y prime equals, it was actually negative 2x, negative x over y. And that's my answer. You could, if you want to, go back and rewrite that as dy dx, but most of the time you get away with just leaving it as that.
Once again, implicit, I want to find the derivative of everything with respect to x. So this is going to give me 12y squared times y prime. Not y to the first, y prime. Plus 2x equals 0. Now I'm going to solve it for y prime. I'm going to subtract 2x from both sides. That's going to give me 12y squared times y prime equals negative 2x. Then I divide everything, both sides, by 12y squared. And this is going to give me y prime equals negative x over 6y squared. And that's my answer for number 2. For this one, I'd like to use the power rule. So I'm going to rewrite this with negative exponents. So that's going to be x to the negative 1 plus y to the negative 1 equals 3x squared. I'm going to start to do my implicit differentiation. So this is going to be negative 1x to the negative 2 minus 1y to the negative 2. Don't forget, y prime, not y to the first, equals 6x. Now I have to solve this for y prime. I'm going to leave the negative exponents for now. So I'm going to add 1x to the negative 2 to both sides. So that's going to give me negative y to the negative 2 times y prime equals 6x plus x to the negative 2. Then I'm going to divide both sides by negative y to the negative 2. Divide this by y to the negative 2. And that's going to give me y prime equals 6x plus, I'm going to rewrite this as 1 over x squared over 1 over y squared. And no calculus teacher in their right mind will let you get away with that answer. So we're going to simplify it. And the way I'd like to simplify this is use the common denominator x squared, y squared. I'm going to multiply the top by that and the bottom by that. Technically, I'm only multiplying it by 1. And that's going to give me 6x cubed y squared. When I do this, times that, plus y squared, because the x squared cancels out with the x squared, all over x squared. And that should be my final answer. This one's a whopper because I have to implement the product rule inside of an implicit differentiation problem. So I'm going to start off, I'm just going to split that down the middle and label this as u and this is v. And then on the side, I'm going to do that work. So u equals x squared, v equals y, du, the derivative of x squared, equals 2x. The derivative of y, the dv, is just y prime, so it's not that big of a deal. Then it's u dv, so x squared y prime, plus v du, 2xy. I prefer to write it in alphabetical order. Plus 4y cubed y prime, don't forget I have to differentiate with respect to x, minus 3 equals 0. Now I have to solve this for y prime. So I'm just going to do some grouping, a little bit of algebra. That's going to give me x squared y prime plus 4y cubed y prime equals, add 3 to both sides, subtract 2xy from both sides. Now I'm going to factor out a y prime, but if you do this enough, you start to realize that when I factor that y prime out, I'll just be left with x squared plus 4y cubed. So I'm going to divide both sides by x squared plus 4y cubed. And that will be my final answer. So y prime equals 3 minus 2xy over x squared plus 4y cubed.